All right, we started graph and tangent yesterday. We're just practicing those skills again. So I think we have six tangent graphs here. We have all the transformations. First thing I calculate when I'm doing tangent is I figure out the period so that we can kind of divide it into the chunks of graph. So remember, the period for tangent, unlike sine and cosine, which was 2 pi divided by b, the period on tangent is always just pi divided by b. So if you look here, because that's where it starts repeating here, our b is 3. So we're going to figure out pi over 3. That's our period, right? And when we were doing our labels, we kind of divided that into two chunks. So if we're calling them our steps, this is how I label my graph. We could take our full period and you could divide it by 2, or you can multiply by 1/2, which this would give us pi over 6. So I'm going to make labels for every pi over 6. Let's see, so here would be 1 pi over 6. Here would be 2 pi over 6, which would reduce to pi over 3. Here would be 3 pi over 6, which reduces to half, right? So pi over 2. Here would be 4 pi over 6. 4 over 6 reduces to 2/3, so it would be 2 pi over 3. So 1 pi, 2 pi, 3 pi, 4 pi. Here would be 5 pi over 6, which you cannot simplify. And then 6 pi over 6 is just pi. I'm going to get those going -2. Negative pi over 6, negative pi over 3, negative pi over 2, negative 2 pi over 3, negative 5 pi over 6, and negative pi. Those are tough labels to work on. All right, great. We've got it labeled out. So some other things that I noticed, the negative in front means it's reflected. So usually tangent graphs start low and end high. This one's going to do the opposite. So I remember that tangent graphs don't have a technical amplitude because they go on forever vertically. But our amplitude-ish thing is this 4. So I'll call it our A. A equals 4. That's it, we're ready to go. So remember, if you label it this way, your asymptotes for tangent always start at your first labels to the right and left of center. So we're going to have an asymptote at negative pi over 6, positive pi over 6. And the way we scale it, if you're consistent with how you scale, it's going to be every 4 spaces there's going to be an asymptote, because every 4 spaces is going to represent one full period. And everything on starts repeating after a period. So 1, 2, 3, 4, there's going to be another one at pi over 2. And again, we could technically be adding a period of pi over 3. If you did pi over 2 plus pi over 3, there should be another asymptote here, a vertical asymptote. Now, you could get the common denominators there. That would be 6, so it would be 3 pi over 6 plus 2 pi over 6, which is 5 pi over 6, which again, if you just keep scaling it the same way, it's every 4 spaces. So there should be another one on 5 pi over 6. It's every period. Over here, cool. So we're going to have our center point between those. We don't have a vertical shift at all, so our center is going to be right in the middle. Tangent, usually, you split the difference between the middle and the asymptote, aka go over one space. And then usually you would go like right one up one, you'd go left one down one, but this is reflected. So it's going to do the opposite, and the amplitude-ish thing is 4. So we're going to go right 1, down 4. 1, 2, 3, 4. And we're going to go left 1 and up 4. 1, 2, 3, 4. So this is how each little cycle, each oscillation is going to look here. Whee! Look how cute and colorful this graph is. My goodness. So this is technically 3 cycles. I think usually we ask you for 2 of them. But there's 3. We're cool like that. We could throw in some bonus cycles for the fans. You know what I mean? I don't see it asking for domain and range, but again, we're cool. We could do that. Domain left and right. It's basically everything except for those asymptotes. So the way we can write that is x such that x does not equal, you pick any asymptote, I see one at pi over 6, plus, and then we say k times a period. A period here is pi over 3, so we could say plus k pi over 3. You could also say pi k over 3, up to you, whatever. And the range is up and down, so that would be all real numbers. So the range, it vertically can go on forever in each direction, so our range would be all real numbers. You could write it like that. You could do the cute R with the line through it. That was fun, right? Luckily, we have 5 more of these. They'll go a little quicker once we get used to it. So here, I'm going to figure out our period first. So period is always pi divided by b. And in this case, the b, it always comes between tangent and x. There's an invisible 1 there. So it'd be pi over 1, which is pi. It starts repeating every pi. Now, I like to figure out my steps for my labels, which is going to be half of that. So you could do pi divided by 2 or pi times 1/2. It's pi over 2. So we're going to label every pi over 2. Here's 1 pi over 2. 2 pi over 2 is just pi. We have 3 pi over 2. 4 pi over 2 is 2 pi. We got the old 5 pi over 2. We got 6 pi over 2. That's 3 pi. And then we'll have the negative versions of that as well. All right. The only other transformation I see here is this -1 at the back. That drops all of our points down 1. That's it. That's the only transformation. So again, we're always starting with our vertical asymptotes at our first labels to the right and left, unless there's a horizontal transformation, which there isn't here. So we're going to have asymptotes there at negative pi over 2 and pi over 2, because that's where on the unit circle, those would be places where we're dividing by 0, and you can't do that. And then it's going to be every additional pi. It's repeating every period. And again, keep scaling it the same way. That's every 4 spaces. So 3 pi over 2, 5 pi over 2, negative 3 pi over 2, negative 5 pi over 2. Great. That's the hardest part, figuring out the asymptotes, where those are, the labels. Now we're going to find our center, but we're dropping it down 1. So we're going to have a point in the center here, but down 1. So I'll find all my center points for all these cycles here. And then it's just your normal tangent graph. So that means we're going right 1, up 1, down 1, left 1. And then we just do our little swoop-de-swoops through those points. Whee! Along the vertical asymptotes, and we're having fun. We're graphing a lot. Cool, let's do our domain and range real quick. Domain's going to be everything except for those asymptotes. X such that x does not equal any asymptote. I'm just picking pi over 2. Plus k times the period. Our period is pi, so we'll say plus k pi. Range, all real numbers. Look at that, 2 down. How about number 3? Oh! All right, so there's no period change, so our period's going to be pi, which means my labels will go by pi over 2 again. Pi over 2, 2 pi over 2 is pi, Then we got 3 pi over 2. And I'll just stop at 2 pi. And then we'll go negative as well. Negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. The only transformation here is we have this plus pi over 2. Remember, if it is grouped with it, that means we're going to shift everything left a half pi. Now, if you look here, we usually start with vertical asymptotes at our first labels, but we're shifting everything to the left a half pi. So if our asymptote is usually at 1/2 pi or pi over 2, and we're shifting left pi over 2, we're going to have an asymptote right at 0. And we have a period of pi, so it's going to repeat every pi. So 0 plus pi is pi, or every 4 spaces if you keep scaling your graphs the same way. I know that's not like the proper way to do it, but our graphs are perfect and they're cute. Yeah, you can keep adding a period and we're good. That's the only shift. So we're going to find our center points. We'll go right one, up one. We'll go down one, left one. Man, I bet you're loving those sound effects at home. Cool. Let's domain it. Let's range it. We know the ranges already. All real numbers. Domain x such that x does not equal. You pick an asymptote. Negative 2 pi, negative pi, 0 pi, or 2 pi. I'm just going to pick 0. Because then we could just say 0 plus, which you could get rid of the 0 plus then. So it's just k times the period, and our period is pi. So you could just say x such that x does not equal k pi. Because remember, k could be any integer. Could be negative 5. There's going to be an asymptote at negative 5 pi. Could be 0. There's going to be an asymptote at 0 pi. Cool. 4. Ooh, we got a reflection. We got everything getting shifted up 3. But the period didn't change at all, so the period's still going to be pi. Our labels are still going to go by every half pi. You're probably getting sick of labeling all these graphs, huh? Well, tough toenails. We got to do it. And again, our asymptotes usually start at those first labels, which in this case, since the period didn't change, would be negative pi over 2, positive pi over 2. And it would be every 4 spaces or every period. We didn't change that at all. We don't have a left and right shift, so that is where our asymptotes are going to be. Negative 3 pi over 2. We got, oh, shoot. I put it in the wrong place. Oh my gosh. That is so embarrassing. Pi over 2, 3 pi over 2. There you go. We could fit 3 cycles in there. Otherwise, you can keep going. You could make one over here if you want. We're all good. Now, it is up 3. So we're going to take our center point, and we're just going to go up 3 with it. And this is reflected, which means it's going to go down and right. It's going to go up and left. Whoop. Whee. Woo! All right. Okay. Here we go. Wow, that one is not as pretty. All right. Domain x such that x does not equal. We pick an asymptote. I see one at pi over 2 plus k times the period. The period didn't change here. It's pi. So plus k pi. Range up and down is all real numbers for all of the tangent problems. 4 of 6 are done. We're almost there. Oh my gosh. Now here, the period didn't change. So it's going to be pi over, for our labels, the period's going to be pi again. Our labels are going to be every half pi because the period did not change. Pi over 2, pi, 3 pi over 2, and 2 pi. We'll go negative. Cool, so the only transformations I see here are the negative in front means it's reflected, so it's going to go down and right, up and left. Also, this plus pi over 4 is grouped with it, so that means we're going to shift left pi over 4. Now, our labels are in pi over 2, but that's 2 spaces. Think of like half and a quarter. A quarter is half of a half. So if our asymptote is usually starting at pi over 2, half pi, and we're scooting left a quarter pi, that's just going to move it over 1 space. So we're going to have an asymptote here at pi over 4. There's not a label there. If you want, you could throw in all kinds of labels. And then it's going to be every 4 spaces. 1, 2, 3, 4. 1, 2, 3, 4. We'll go left. Cool, so we don't have a vertical shift, so our center will be right in the center. And this is a reflection, so it's going to go down right, up left. Whee! All right. Woohoo! Fun! Look at us. We're learning and graphing trigonometric functions. Cool. Domain x such that x does not equal. We have an asymptote at pi over 4 plus k times the period. Our period is still pi. Range 4, all of these is all real numbers. We only have one problem left. Are you a little sad that we only have one problem left? I don't blame you. Here it is. Oh my gosh! This is unbelievable. So, first thing I notice is we have a b that's not 1, so that's going to change our period. I think I have to sneeze. Maybe not. Maybe it's just a windjammer up there. It's going to surprise me here. So a period is usually pi divided by b, and here we finally have one. It's 2. So our period is pi over 2. It's going to repeat every half pi. Now my steps for my labels, we're going to take that and we're going to divide it by 2 or multiply by 1/2. That'll be pi over 4. So I'm going to label every pi over 4. Here's 1 pi over 4. Here's 2 pi over 4, which reduces to pi over 2. Here's 3 pi over 4. And 4 pi over 4 is just pi. We'll go to the left as well. Negative pi over 4, negative pi over 2, negative 3 pi over 4, and negative pi. Cool. We don't have a left or right shift, so our asymptotes are still going to fall at that first label to the right and left. So pi over 4, negative pi over 4, negative 3 pi over 4, and positive 3 pi over 4. Every asymptote is a period away from each other, a pi over 2. So other things I see, this minus 4 at the back will drop everything down 4. The negative in front is a reflection. And the 3 is like our asymptote-ish thing. So we'll find the center first, but our center is dropping down 4. 1, 2, 3, 4. It's reflected, so it's going to go down to the right. Now it's going to go down 3, which is going to kind of go off of our graph, but we'll throw a bonus point down there. Now we're also going to have to go left and up 3. And we'll just pretend like I can actually draw lines through points.
Just use your imagination. Pretend like old Mr. Plant can do that.
All right, domain x such that x does not equal any vertical asymptote. I see one at pi over 4 plus k times the period. Our period is pi over 2, so k pi over 2. Range, you know it, you love it. It's all real numbers, folks. We're done.